Okay, I started here by solving the exponential equation 5 to the power x minus 4 equals 3 to the power 2x. Now, since the bases are 5 and 3 and we cannot make them equal, the only way to solve this problem is to take logs on both sides. And this is one of the properties of log. If you have, let's say, an x equals a y, you can take log x equals log y. That's one of the properties of logs. So I just took logs on both sides. Since there is no base here, then I'm using base 10. Okay, you can use any base. Then the next step, I use this property. If I have an exponent, I can move it as a coefficient, b log x. So here I have an exponent, so I'm moving this exponent as a coefficient, and I'm using also this exponent as a coefficient. That's how I got the step number 2, x minus 4 between parentheses log 5 equals 2x log 3. I put parentheses here just to make sure that x minus 4 is multiplied by log 5. Now, this time I'm going to distribute, so I'm going to multiply x times log 5 and negative 4 times log 5. So I get x log 5 minus 4 log 5. Here, I just keep it 2x log 3. Now, this is a linear equation. To solve a linear equation, you need to separate variables, put the x on one side, move the constant to the other side. So to move the 2x log 3 to the left, I must subtract 2x log 3 from both sides. And that's how I end up with x log 5 minus 2x log 3. Now, to move the minus 4 log 5 to both sides, I have to add 4 log 5 to both sides. And that's how I end up with x log 5 minus 2x log 3 equals 4 log 5. Now, I need to solve for x, so I take x as a GCF. X is the GCF among these two terms. So take x as a common factor. What is left from the first term if you remove x? Log 5. What is left from the second term if you remove x? Minus 2 log 3. And of course equals 4 log 5. The last part, I need to divide both sides. So I need to divide both sides by log 5 minus 2 log 3 in order to isolate x. So x would be 4 log 5 over log 5 minus 2 log 3. Now I changed this whole denominator to log 5 over 9. And the way I did this, I started by log 5. I started by log 5 minus 2 log 3. I used the property to move the 2 back as an exponent. So this is log 5 minus log 3 squared, which is 9. And then I used also this property here. When you subtract logs, you can write them as a quotient. This is the quotient rule, so it would be 5 over 9. And that's how I got this denominator, log 5 over 9. Now I use the calculator to find the final answer, and they want it rounded to the nearest thousands. That's why I have only 3 digits after decimal, because they wanted to round it to the nearest thousands, and this is the final answer.